Welcome to.
This meeting is being recorded.
Are we? Yeah, we can start. Cool. Yeah, welcome to Women Who Code's object-oriented programming track. We are launching this today, which is very exciting. We launched an algorithms track last year, and that was very successful. Few women got job offers out of that, so that sounds really awesome. So we're keen to pursue this series of talks and help each other improve more on these technical topics. And for the object-oriented programming track, we're going to cover all sorts of different topics in this area. And so this is very exciting for us. So what is the track? So fortnightly, we will have talks that is all organized by Irina. We appreciate her a lot in this community. She's superwoman in organizing all these events. And so we'll all start to explore the object-oriented programming paradigm. So some talks will probably have exercises in them. Actually, in my talk, there's also an exercise. And if we run out of time, as Irina said in the beginning, remember to join the Slack channel. There'll be a Slack channel there called Object-Oriented Programming, where we can carry on discussing the exercise if we do run out of time. So yeah, a little bit about me. So as I said, I'm Jamica. I'm an engineering manager at Thought Machine. So I've been working for, I guess, a total of 15 years now, but the last 4 years have been as a manager. So I'm not coding day to day, but I do like to keep technical and keep myself up to date. And I volunteer a lot around women's technical groups, Women Who Code London being one of them. I also mentor in both in this group and in Women's Society of Engineering. I'm really passionate about helping women advance in tech. And yeah, I've worked in different cities. I was born in Manila originally, but now I'm here in London. I've been here for about 8 years now, so that feels like a long while. So yeah, let's talk about object-oriented programming. I mean, what is it really? It's a paradigm, and what that really means, it's a pattern, a model, a way of thinking about things. So I think we do this on the day-to-day. We have a model of things in our heads. We know what a tree looks like. It's got a trunk, it's got a leaf, it's got branches. It helps us represent ideas or concepts as code consistently. And the term consistently, in my mind, is quite a key thing about creating models, because it helps us come to a common understanding of how we represent data and behavior in our software applications. It's based on the idea of grouping related data and functions onto a single thing. So the groupings is something we could call objects. We can also define this as compared to other paradigms. The one that most people come to when they first start coding is probably procedural programming, where you linearly do one step on the next and data is received in a function, and then you proceed linearly to the next step. So script is quite common. A script will run, do something with an input, and then produce an output. Pretty straightforward. So that's what people call procedural programming. And then you can compare that to functional programming. So functions, they do not store data. You also hear the word state quite a lot. So functional programming doesn't store state. What it does, it transforms them. And we can explore a little bit later what this really means in practice. So it's more about the functions of computation. Quite a lot of them are deals with computation heavy problems, and they don't store state, so they don't store data or attributes. And this is in opposition to object-oriented, where you care a lot about the data, what's the behavior, and you also keep on keep in state its attributes, so the data you need in order to make decisions. So that's object-oriented paradigm in a nutshell. But what does this really mean? So how do you do this? So the first thing really is to think about it conceptually. So in a given domain, so say you're a developer, you're given some sort of requirements. You, at least this is how I do things. So I identify actors. So what does that mean? It's a thing that does something or that has a behavior. And then I look at what they do. So I've got some examples here. So for example, I work in fintech. So you'll find my examples are like banky concepts. But here you've got, a card, which is an actor. It makes a payment. So that's an action. Or a window can be minimized for the web developers out there. Or a button can be clicked. An email is archived. So you can start imagining how you do this kind of modeling, like in all the things you interact with in the world, and you can pretty much translate that into some sort of concept. And this act of thinking about the domain and representing them as a concept is widely referred to as modeling. Lots of people might not call it this, people might call it like requirements interpretation, but at the end of the day, it's a skill that is quite important. You do this a lot. It's quite intuitive because we like to think in terms of the things that interact with the world. So this is modeling. So it's learning to identify the actors, the data you need, and the type of interactions taking place. So the examples I mentioned earlier, right? So a card creates a payment to an account, for example. You are thinking about who or what interacts with another thing. So here, a card would create, when you say a card creates a payment, it refers to the objects that have a behavior. So you can think of it as actors are the objects. So in the example, you've got a card, you've got a payment, you've got an account. You've got traits, which could be what would be the attributes of the object. And these are important because they might be things that you need in order to make a decision or enforce a behavior, which then that brings us to the functions. So here, the last example is actually a kind of a behavior where an account can reject or accept a payment. So if you were to write a function, so if you were to define a behavior, which is practically means you're going to write a function, that means that you have to think about what's the pieces of data, what is it about that account that lets you make that decision. So that's the attribute of your objects. So then, this brings us to, what does it really mean in practice, right? So object-oriented programming is really about translating these models into code. And this really is a kind of a mapping of this, these three things that we've identified when we were doing the modeling exercise. Is we identified actors, traits, and behavior. That means you've got an object, attributes of that object, and how it behaves. So what does that really mean in code when you start coding? And so objects in code, in most programming languages, well, at least in everything I know, it's represented by classes. And a class, so the examples I have here is in Python, by the way, in case, that's why I was running a little poll earlier. Okay, most people are preferring Python, so great. So yeah, so we've got classes, which is a data type, and so if you haven't coded in Python they've got data types, int, string, and class is just another data type. It's a data type that acts as a template. So it's a thing that tells the interpreter how to instantiate or create this object. So in Python, it's very simple. You use the keyword reserved word class, and then what you want to call it, and then that's it. That's an object. So in my example, again, if we were to look at this one, it says, we want to model an account. We want to think about an account. That's my object. I'm just going to call it account, right? So simple bank account model. So what could be the attributes of this account, right? So the example here says, an account might want to reject or accept a payment. And so if I want to roughly think about that, maybe you want to reject a payment when you reach an overdraft or something like this. So there's some conditions with which an account can reject payment. Maybe it's not an open account, so it hasn't been opened yet, so on and so forth. So these kinds of requirements, you would look into them so you can determine or discern what are the attributes of your object. So later in the exercise, there's quite a few requirements that I've put together that would be the requirements that could help you determine what the attributes of your objects are. So in this case, maybe an account name is an attribute, because if you think about it, if you accept or reject payment, maybe that's not the correct name of the account that someone is transferring money to, these kinds of things. So it's the data that you need to make a decision. So these are things that you consider as attributes. Variables in an object hold its state. So if I wanted to declare that my class has the attribute of state, as in open, close, pending, then that would be a variable I would declare underneath the account class. In the case of Python, you don't really need to explicitly declare it. If you go account dot something, that's you accessing the attribute of that class. And in Python, when you want to create an account or initialize an object, you just say account, and that creates an account object. What that really does underneath the hood is that it runs things like a constructor, which we'll get to in a moment. So looping back a little bit into the modeling exercise, when you think about how to model your objects, there are lots of methods about what they call object-oriented analysis. So if you do a little bit of a Google search, there's millions of ways that you can try and practice how to model things. These questions, they fall under a specific method called the Cordo-Yurdon method. And it's just a series of questions that help you think about your model. So for example, will the system need to remember information about this class of objects? So in the case of an account, things like the state is probably something you would need to keep on hand every time you need to do a behavior, execute some behavior, whether that's accepting a payment or closing the account. Maybe you need to reference the state of the account. That's an example. Another good question to ask is, do the objects in this class have identifiable operations that change the values of these attributes? So that's why in some classes you will find, especially in Java, it's quite common, they call their function names like something manager, because if you need a class that manages state, then maybe this is something that you need to keep in mind, and that could be an attribute of that class, or that could be something that you need to write a getter and setter for, which we'll also get into in a moment. Then again, multiple attributes. If you end up creating a class that only has one attribute, maybe it's better represented as an attribute of another class. Maybe maybe you have a bigger class that already exists and you're initializing a class just to hold that one attribute. Also useful to think about when you're trying to model. Um, Common attributes, you have to think about whether all the instances, all the accounts in your bank system, for example, will have attributes that are shared within all those instances. For example, an account name. Every single account must absolutely have an account name, for example. So that's a kind of attribute that you know exists across all the objects in your system. And common operations. So are there classes in your system that have operations that are shared with all the instances of its objects? So all the accounts in my bank need to be able to know how to close themselves, for example. So those behaviors is something that reiterates the need for having a class or representing that object as part of a class. So going back to our class account class example, there is this thing that happens under the hood, which in Python. In Java, you explicitly declare them, which are the constructors. So in Python, there's this special keyword called underscore underscore init. And it has this, it's a function, just like any function. You declare it using this reserved keyword def. And it's got two, in this example, it's got two variables that you can pass on to it. And a constructor is basically a function that runs every time you create your object. So in this case, if I wanted to say, well, I can only create an object when you supply it a name, otherwise there's no point in creating that object. So then that means that I'm passing a name attribute, I'm populating the name attribute, and then automatically setting it to pending. That's my logic, for example. Every time someone creates an account, I want these things to happen. So that's what you want to put in your constructors. And in this example in Python, this is how you create an account if you wanted to send data in the constructor. So in this case, I'm creating an account with the name Jane Doe. And what that does is it'll populate new account with the name of this value and automatically set its state into pending. So recall our modeling exercise, actors to objects, traits to attributes, behavior into function. So think a little bit about the function of opening an account. So if I wanted to do that in Python, again, it's a matter of declaring a function. So I want the class to have some behavior every time every time I want to open an account. So it's declaring a class function. Again, similar syntax. You supply the variable that you want to populate or want to initialize when you call that function, or whatever it is that you need to execute that behavior. Now there's this curious variable here called self. And what that really means is, well, it's referencing the attribute of that object. If you don't use this keyword and you just say number, then that's like a normal variable that gets destroyed after this function completes its execution. So it doesn't get saved in the object. So that's just what that self keyword there does. So in my case, I create this function, open account, and maybe have a function somewhere called generate number, and it creates the number, account number, because I don't want that to be, and this is a really interesting feature of object orientation, right? So I don't want this number to be just populatable by anyone. And so I would like that number to be auto-generated. So this function effectively changes this value when you call it, but the caller doesn't have to do anything. And I just need to tell it, how much money I want the account opened with. So there might be a bunch of logic here involved in opening your account. So you might want to put that logic there. And then once you have some money in your account, then you can declare it open. So what that means is someone who is initializing and creating an account object that might be, it will look like this. So new account dot open is basically how you call the class function in Python, and then the amount that I want the attribute to be populated with. So the thing about the number that I was talking about, this concept is called encapsulation, and it's a really important feature of object-oriented programming. So in Python, when you declare variables like this, they are public. In Java, these variables are explicitly declared as public or private. And what does that mean? So these variables means that public, they're accessible from outside the class. So in Python, that's not enforced strictly, and I'll explain that in a little bit. But in Java, if something is not public, then you won't be able to set the value of that attribute of that class directly from outside the object. So I've got an example here, right? So let's say I'm some dodgy developer and I wrote some dodgy code, and I create some account called Bob Bobson, and I just set the balance to, make Bob rich. And this is what it means. So balance in this case is exposed. I don't really need to call this function to set the value of balance. And that's what it means when attribute of a class is public. In Java, if it's public, you can do this too. If it's private, it will error out. You can't access private variables in a class. So this is why I was curious, who are the Java developers and Python developers in the audience? Because there's these subtle differences between programming languages. It's just useful to know when if you decide to practice with Python, then just keep in mind that technically you can access variables in this way. But there is a way to communicate that in Python. That doesn't mean they just didn't care about that. In Python, you declare variables to be private with the double underscore. And so that means you shouldn't be setting, if you are a developer joining a developer team and you find the code base that looks like this, then you know that these should be private and you shouldn't be directly setting the balance attribute in this piece of code. And it should protect, and this is the main point of encapsulation. You restrict access to certain attributes or even functions. So in Java, you can declare functions, and in Python, you can create functions that have double underscore here as well. And in fact, init is one of them. And that would be declaring it as a private function. So in general, it's a good practice to keep to the paradigm that if you want to change the state of your class, so in this case, balance, you invoke the function that changed that rather than accessing it directly. And this is generally a good practice when you practice OOP. That's the whole point of encapsulation. So, in good practice, if you want to stick to the OOP paradigm, when you open an account, that's the only time you can set balance value. That's the only time the state can be open. And that's important because we want to make the behaviors of the classes deterministic. Like we know just from looking at this code that account can only be open when you invoke open account and you supply a value to it, for example. So that's the usefulness of encapsulation. Another useful feature of OOP is abstraction. So it hides the implementation details of an object. So in the previous example, a program opening an account, you can supply it a name. Open account, a balance, and then it will create the balance. All the logic is behind the scenes, right? So you might have a bunch of other logic here. It will generate a number, but someone who's calling open account need not know those details. It only needs to care about the interface. So what is it required in the functions for me to use that, for me to invoke that behavior. So that's another useful feature of abstraction. So what's the other feature of OOP is inheritance. So inheritance lets us reuse the same class with shared behaviors. So extending our example a little bit, so you've got an account, and maybe there's different types of account. There might be a current account, which is something that you use daily. You might put in money onto it, and then you spend the money that you put in there. And then another type of account is a loan. So if I think about it, a loan puts money in my account. So maybe it's possible to have a negative balance. So then you'll have a different function. But everything else about a loan is the same as any other type of account. So you can have, it also needs to behave in the same way as when you open an account. I want it to generate me a number, I want it to have an initial amount, and I want it to open, for example. So if in Python, this is how you declare inheritance. So you create your new class, and you pass in as an argument to when you create the class, the parent class. In this case, it's an account. So what that does in practice is that a loan will also have this behavior and this same behavior. So you don't have to rewrite those functions when you create a loan. So that's the usefulness of inheritance. You can reuse behaviors, you can reuse attributes that you know is common across all your account types, right? So recall that, when you think about common operations and common attributes when you're modeling, this is when you start thinking about whether you need to do inheritance in your classes. In Python, you can override certain, whatever it is that is in your class. If you want to override, say, open account to have a different check, you can do that by just declaring the function with the same name in your class. That overrides it. And you can have functions that is unique to this specific class by just simply declaring a function for that class. In OOP, you also find frequently that there are things that are called getters, setters, and decorators. So because if we want to keep to the encapsulation and abstraction, right? That means we only want to change the state, the attributes of that class by invoking its functions, right? Then maybe you want to create functions that get the values, so you don't access, because especially in Java, you're not able to access private attributes. But then maybe there's a need for you to access that. So then you invoke functions to get the values of these. So in this case, I created a get balance function, and it'll return the value, and setters, so it sets the value. So set balance may be something you need in your modeling. So in my normal bank account, I want the value to always be positive, for example. So the setters protect the class from having bad values. Sometimes in some programming languages, they're called accessors and mutators. So just make sure to check what is the general practice in the programming language that you are using. So then comes the question, when do I even use object-oriented programming languages? So if you recall, you've got procedural programming and functional programming. So it's one of the many available paradigms. If you look at most programming languages, they have a mix of all of these features. So Java has functional support. You can, map reduce is a good example of that. When you reduce values in single function call, that's probably functional. And it's all about trade-offs, pros and cons. I personally take the stance of pragmatic approach, which is I look at the problem that I'm trying to solve and see what might be better, what paradigm might be better to apply. And sometimes it's a mix of these different things. So to help me think a little bit about OOP, I always think about the pros and cons, because that's in general is what software development is. You make some trade-offs. There is no perfect solution to everything. So you've got some pros. So it's quite intuitive, right? I think we do this quite a lot when you talk to people, make metaphors to describe something. That's a form of modeling. So it can feel very intuitive once you get a hang of it, once you do it quite a lot. In some cases, it becomes like a default way of solving problems. Data encapsulation, as I said, you can control and make the behavior predictable. So in the examples I presented, you can take a look at the way at which attributes are public or private, what attributes are set when certain functions are called, and this helps you predict, make it deterministic. A lot of people tend to use that term, which means the result should always be the same. If you do your model well, it should be easy to maintain. So if you have a class that has a parent class that has an attribute and you change it in one place, all the inheriting classes will get that change also. You can reuse things, so the usefulness of inheritance, if you keep it simple, you can make your productivity better because you don't have to rewrite a bunch of code. And this is really where that comes in. Of course, there are cons, right? So like anything, if you're not used to doing this, it can take a bit of practice to get good at modeling. In legacy code bases, it can be complicated to maintain, especially if over time lots of people have written classes that inherit from parent classes and then that person has already left. So then you end up if you Google the diamond inheritance problem, for example, that's one common problem I see in organic legacy code bases, where people, let's inherit from this class, I'm just going to write that, and then someone wrote another class that inherited from that other class, and so that can get quite hairy. Complexity. So lots of people who have strong opinions against OOP would tell you that state or mutable state is their main problem with OOP, and that's not without reason. It can be quite difficult to debug once you get to things like concurrency. If there are like concurrent processes that access the same class and they both need to mutate that state, that can make the system behave in ways that you can't really predict. So these are just things to keep in mind when you are designing your system. But for the most part, unless you were writing some massive, I don't know, I think people who work in databases, for example, they would have to think about this a lot. But if you were working in a web application or an app, I think for the most part, OOP works quite well. So I like to take that stance. But there are numerous debates about, OOP versus functional. I've provided some links in the presentation, which I can send later, so you can kind of make an opinion for yourself. But I think you have to have worked with a lot of object orientation to be really against it. I think, because for the most part, it's quite useful. It's a good tool to make sure that everyone understands what your objects are and how the things are represented in code. So I don't think it's like the worst thing in the world, right? So now I've got an exercise here. I think we're still good for time. So if people are open to trying this out, please do so, especially the ones who are already doing things in Python. Then you can try and create classes with this example. So this would be like this is a good example of a kind of requirement specification, really. And you can model. If you haven't got experience in any programming language, I think this is fine. You can still create your models conceptually, and then use that as your practice for whatever programming language you're trying to pick up, and create classes in that language. So here you've got a nutritionist tool, right? So this is a kind of spec. So if you're gonna develop a tool for nutritionist, it outlines here what the functionality of the app should be, and what we expect the users to deal with the app. And then you've got requirements here, which I guess it defines the behaviors of your whatever objects you decide should exist in order to build this system. And so highly encourage you to try and model this system. We can break out in small groups and try to work out what would be a good set of objects to use in this exercise. I've also linked in this presentation further reading. So if you want to learn more about domain modeling specifically, and I highly recommend this for people who have aspirations to become product managers, for example. This is quite useful because you also use modeling to discuss application specifications, and it's a really good tool to communicate your requirements to developers. So learning how to do this domain modeling and discuss objects conceptually is really, really useful. So there's a whole field just on object-oriented analysis. And there's like lots of methods that people have developed to extract information from requirements and turn them into objects. And then if you're a developer, you can turn it into classes, basically. And again, there's loads of debate between OOP and functional. I found this Quora thread that really explains both sides, tells you which approach is good for what situation, and what are the features of those two paradigms that is useful. And you'll find for the most part, most answers say they're both useful. You use them for different situations, and most of the time, practically speaking, you use a combination of both to solve a significant problem. And I have a copy of the slides with Java examples, if there are Java developers out there or aspiring Java developers. So you can try out the classes, create classes in Java. Cool, and that's the end of my presentation. I don't know if there are questions from the audience. I think we've got 5 minutes. As I said, if you want to continue discussing if you want to take a stab at the exercise and want to share the outcome of your practice, then just share it in the Slack channel. So I highly encourage you to join our Slack channel so we can review each other's classes. And then as we progress the series, maybe you can use that same model that you have to apply other refactoring and patterns that we're going to discuss in future presentations. So just an idea, but in your own time, because I would say I would have a good sit down here and think about my objects, attributes, and functions. So so yeah, if anyone's got questions, open to do so. But if not, yeah, that's the end of my presentation.